Hello, welcome back to a little bit of chemistry practice. In the last video, I went over the basics of acids and bases, and we just looked at the Arrhenius definition. There are a couple of other definitions, and I'm going to go over those later. But right now, we need to concern ourselves with what do we need to know to calculate pH or pOH. In the last video, I mentioned there was this nice little equation here. So I put these little equations on one sheet so we can review them and then do some examples. Now, if you want to know where these are coming from, go look at the last video. At the moment, we just need to memorize these. So pH equals minus the log of the hydronium concentration. When we say concentration, we mean molarity with a big M. And if we say molarity, remember we mean how many moles are there per liter of solution. So moles of solute per liter of solution. That is back in the unit on solutions. Now the solution is going to be water. The solute will be whatever we decide to put in there. Could be hydrochloric acid, could be nitric acid, could be anything else. Okay, and remember that this is a ratio. We can also calculate the pOH, which is minus the log of the hydroxide concentration. Now, if we can do this calculation, keep in mind we can rearrange these equations to then find out what this concentration is. Let's say you have a question where they give you the pH. The pH of this is 3.4. What is the hydronium concentration? Well, in that case, I rearrange it for you. We would actually get 10 to the minus pH. Now you have to remember to change the sign on that, otherwise you're going to get a wrong value. But on a calculator, there's normally a little button. It varies per calculator, so that's always the problem. That will say E, and then it'll have a little box up here. So if you hit that, you can put in your negative pH here and hit equals, and it's going to give you this number. Now, if I have the pOH number, I can do the opposite. And of course, remember, pH plus pOH equals 14. Now in the last video, I said that we use this pH scale from 0 to 14. Can things be below 0? Yes, they can. Can things go above 14? Yes, they can. But not commonly, and in introductory chemistry, we're going to focus on the scale 0 to 14 to make it easy. Okay, so let's move on to a few examples. In class, there were a couple of worksheets. I'm not putting the whole thing on here. This is just quick review where it said calculate the pH or the pOH. Okay, so number one, a 0.023 molar solution of perchloric acid. Okay, now I don't think they're trying to trick you right now, but we could just write down the formula here, which is going to be HClO4, perchloric. And just keep in mind when this dissociates in water, it's going to have one hydronium ion, or you can call it a hydrogen ion or a proton. Remember, there's different names for it. Don't get confused. Plus ClO4. So this is the anion. This is the cation. Now, notice this is a 1-to-1 ratio. For every one of these, I will have one of these. Keep that in mind because that's going to be important later. This is very simple. All I have to do is take minus the log of 0.023. So on my calculator, I'm going to do that real fast. Minus the log of 0.023 equals 1.64 basically. So my pH is 1.64. Now, how do I find the pOH? I go back to my calculation. pH plus pOH equals 14. So 1.64 plus POH equals 14. So 14 minus, I'll minus this from both sides, minus 1.64 minus 1.64. 14 minus 1.64 equals about 1.24. Sorry, my calculator messed up here, about 12.4. My calculator's in scientific notation, so 12.36, somewhere around there. Okay, what is this really telling us? Remember, if the pH value is low, it is more acidic. If the pH value is very high, it is more basic. Okay, so really this is telling us this is very acidic. This is pretty strong on that scale. Now let's move on down to the next one. Get some room here. Now they're going to get tricky. Instead of giving us a nice little molarity and a small number here, they're going to give us this number in scientific notation. This is nitric acid, which yet again is going to be a 1-to-1 ratio, so we don't have to worry about the dissociation. And yet again, I'll just take 6.6 times 10 to the minus 6, because that is my concentration. And I will put this in this minus the log of this number. So I'm going to go ahead and do that on my calculator. Minus the log of 6.6 times 10 minus 6 equals, and I get a pH of around 5. I'm just going to round up, make it easier, 5.2. Okay, so 14 minus 5.2 will give me the pH. All right, so I'm going to get 8.8 or so. Yet again, this is decently acidic. Remember, if it's below a 7 on a pH scale, if it's below a 7, it is acidic. And this makes sense because this is an acid. They tell us that right here. Okay, down here we have potassium hydroxide. This is what confuses people. First of all, potassium hydroxide is KOH. And when it dissociates, I will get K plus my hydroxide. Remember, if I have hydroxide, it makes it basic. So I can't use minus the log of the hydrogen ion equals pH. I have to use my other formula. I have to use POH equals minus the log of the OH. So I'm going to look for the POH. I'm going to get this number first, then go and get this number here. So my basic advice is, when you are looking at a question on a quiz or a test, figure out if it's an acid or a base first. Then plan your attack. Then use the correct equation. And then calculate the other value. So I need to get minus the log of 0.0334 equals 1.4. Okay, so 14 minus 1.4 is going to be about 12.6. So what does this tell us? Well, we know this is a base, and a base is going to have a very high pH, which it does, and that makes perfect sense. So after you calculate these things, always go back and ask yourself, if it's an acid or a base, my pH needs to be in the right range. If it's not, you did something wrong and you need to go back and recalculate it. Okay? And I think one problem people make in these calculations is there's so many different calculators out there that sometimes it gets confusing about the buttons to push. And so that's what you got to be careful about. That's a common error. I make that error myself all the time. I'll be doing the thing right, but I will use the calculator wrong. So it's important to use one calculator and know your calculator well. Okay, Let's go down. On the next page, they wanted you to calculate the pH of these problems here. So we have a 4.5 times 10 to the minus 3 molar solution of hydrobromic acid. Yet again, when this dissociates, it will be your hydrogen ion plus your bromide anion. So that's a 1-to-1 ratio. So I'll just go back to my pH equals minus the log of my concentration, and I will do that in my calculator. Minus the log of 4.5 to the minus 3, and I get about 2.35. That's easy. Let's move down. Well, this said calculate the pH, and here's one of those things where they're trying to trick you again. They do that all the time in chemistry. This is potassium hydroxide. This is a base. So it will dissociate into potassium and hydroxide. Now, it is also a 1-to-1 ratio. If I look at where this is at in the periodic table, I know that this is a +1. So this has to be a -1. This is where it is good to know polyatomic ions and ionic compounds well. Because if you don't, it's going to catch up with you about right now. So, I need to calculate pOH first. pOH equals minus the log of 3.67 times 10 to the minus 5. And I will do that now. Minus the log 3.67 10 to the minus 5 equals about 4.44. Okay, and that means I have to go back and plug that into my pH plus pOH equals 14. So this is pOH. So pH equals 14 minus 4.44, which is going to give me about 9.56 as a pH value. Now let's ask ourselves a basic question. This is over 7, so that means this is a base. It tells me it's a base right here, so this does make sense. Okay, we're making some progress. Let's move on down. They had a couple of harder questions in the packet to kind of see if you're paying attention. Let's do those now. A solution made by diluting 25 milliliters of a 6 molar hydrochloric acid solution until the final volume is 1.75 liters. Wow! How in the heck are we supposed to do this? Well, this is one of those questions where they want you to remember something from a previous unit. In the previous unit, which was the unit on dilutions, we have to ask ourselves molarity 1 and volume 1 equals molarity 2 and volume 2. That's the equation we had when we were diluting solutions. So, let's look at this. Do I know any of this information? Can I put this in here? I have, think about it, I have a nice little solution of 25 milliliters. It's a 6 molar solution. So I have this right here. I can put in molar 6.0. Here's my problem. This is in milliliters, but I want to basically fill this up. I'm going to put water in here until it's up to 1.75 liters. So I need to make sure that my volumes match. This is a liter, this is a milliliter. I'm going to change 25 milliliters into liters. And this is where I take 25 milliliters and I'm going to divide it by 1,000. Now I could also use the King Henry doesn't usually drink chocolate milk, which I've shown you many times before, if that makes better sense to you. So 25 divided by 1,000 is 0.025. 0.025 liters equals, I don't know what this molarity is here, but I know I'm going to get 1.75 liters over here. So I do this math here. Really what I'm going to end up with is, let me rewrite this. My M2 is going to equal 6 times 0.025 divided by 1.75. Now if I do that math, I'm going to end up with 8.57 times 10 to the minus 2. That's my new molarity. I know you're like, whoa, what is all this? But just remember, this is like 0.00857. That's my new molarity. Now let's ask ourselves, does that make sense? Well, when I had very little of my solution, I only had 25 milliliters, which is not much. It was 6 moles per liter. So it was very concentrated. When I added a lot more of my water, my solvent, it's going to dilute that. So this number should be smaller than 6. It should be a lot smaller, and it is. So that makes sense. Now, I need to find the pH of this. Well, I already have my molarity. This is my molarity, which is my concentration. And this is a 1-to-1 ratio, so I don't have to multiply this hydrogen ion by 2 or 3 or anything. So I just need to put this in my calculator. Minus the log of my concentration should equal my pH. Let me do that now. Minus the log of 0.00857 equals. And I got a pH of around, actually my pH seems to be slightly off. Let me recalculate that. Minus the log of 8.57 times 10 to the negative 2. And I got about 1.06. Okay? So, this is very acidic, and that makes sense. Yet again, ask yourself, does that make sense? Hydrochloric acid is one of the strongest acids that we have, so that makes perfect sense. Okay, the last one here, 5 liters of an aqueous solution that contains 1 gram of hydrobromic acid and 1 gram of nitric acid. Wow. Well, now, what do we need? We need concentration. Concentration is molarity. Molarity equals moles per liter. Okay, we can do this. Let's just figure out how many moles of this stuff we have. And how do I figure out how many moles? I have to find molar mass. So if I go to my periodic table, I look up the molar mass of hydrogen and bromine, I'm going to get about 80.91 moles per liter. Or I'm sorry, per 80.91 grams. That's how much it's going to weigh per mole. So if I have 1 mole of this, it's going to weigh 80.91 grams. Okay, well, I have 1 gram. So my grams are going to cancel out. So really I have 1.0 divided by 80.91 divided by 80.91. Sorry, I'm doing a quick calculation on my computer. 1.0 divided by 80.91. And I get 0.012 0.01236 moles. Alright, let me just keep that there. I have that many moles of my hydrobromic acid. Now I'm going to do nitric acid. Nitric acid is HNO3. You know, I just realized there's several pieces of information you need for this. Number one, you need to be able to write a formula of the acid from a description. So if you can't do that, you won't be able to do this problem. Then you need to figure out the molar mass and do some basic calculations. So there's several steps in this you need to know. So HNO3, go to the periodic table, look all this up. It's going to be about 63 grams per mole. 63 grams per mole. And how much of it do I have? I have 1.0 grams. So yet again, I have 1.0 divided by 63 equals 0.0158 moles. Okay. Now I have to ask myself a question. This is a 1-to-1 ratio, so when this breaks up, I'll get the same amount, and I'll get a hydrogen ion plus a bromide anion, and HNO3. Okay, that's a minus. So all I have to do is add this amount. I'm going to get that amount of moles of this. If I put it in a solution, I will get this amount of moles of this, and I just have to add these together now. So if I add these together, I'm going to get about 0.02823 moles. Okay. So I have 0.02823 moles of basically these hydrogen ions in here. Well, I need to know the concentration, the total concentration. So molarity is going to be moles per liter. Well, I have that many moles. Sorry, this is sort of cluttered. 0.0282. I have that many moles of solute. How much solution do I have? I have 5 liters. Divide that by 5. So, let me go ahead and do that right now. And let's see what I got. 0.0282 divided by 5 equals 0.0564. 0.0564. That is my concentration of hydronium ions, of hydrogen ions in this solution. So to get pH, I now use minus the log of this concentration, and I should have an answer after all that effort. So let's do that. Minus the log of 0.0564 equals, oh, I'm sorry, 0.00564. I didn't write down my calculation properly. I apologize. So minus the log 0.00564, and I'm going to get around 2.24. And that makes sense because I have a combination of hydronium ions in here and some decently strong acids. So we did a few basic calculations. Let's just go back and review real quick. We learned how to find pH given the hydronium concentration. We learned how to find pOH given the hydroxide concentration. We learned how to find the hydroxide and hydronium concentration given the pH and pOH. I'll try to do some examples with that in the next video. And we learned how to use pH plus pOH equals 14. So I hope that helps. I'm going to do a few more videos, probably one on titrations and one on balancing these equations, and then I hope that's going to help you for the test. All right, thank you and have a good day.